I'm Dipankar Raychaudhuri. I work at Rutgers University, where I am a professor, and I also run an industry university research center called WinLab, which is a center that focuses on wireless. So there are many challenges, and it's also a great opportunity because I was mentioning in my speech earlier today that the core technology for wireless has improved significantly. Cell phones, laptops, Bluetooth devices, everything has become cheap and small. So that's a huge opportunity for business and creating new products. But the difficulties are, as you mentioned, that there are challenges in security, but there's even more a fundamental challenge in capacity that we're facing right now. So what's happening is that as the number of wireless devices is exploding, we begin to run into spectrum limitations. So one of the topics that we work on at WinLab, not covered here, but that's also an equally important topic, is how to fit all these devices into tiny amounts of spectrum that we have. So the US FCC, that's the Federal Communications Commission, has recently initiated quite a lot of work on this area. There's an attempt to make spectrum a lot more efficient, 10 times more efficient over the next few years. So this will be a huge challenge for the industry. The second technical challenge is that of building usable networks with this profusion of different kinds of wireless devices. So we see the cell phones are attractive to people, but everybody has Wi-Fi devices, Bluetooth devices. So putting all of these into a single unified network that works nicely and isn't confusing to users, doesn't have difficult privacy and security settings, the whole thing is a big open problem. So today, of course, each operator has some solutions. Apple and AT&T have some solutions for iPhones. Verizon may have a solution which applies to some set of devices which they support, but these are initial solutions. We need a universal solution where you can own any wireless device, connect anywhere in the world, get seamless communication. So that's a hard problem. It involves architecture, network technology, software. A lot of industries come together in that. Right, so I think that's a very good question. From the point of view of academic research, we are taking a step back in order to understand fundamental solutions. So I just started a project with my team called Future Internet Architecture, where the government is paying the team a total of about, it's a $8 million big project, which is aimed at what we call clean slate. So clean slate is this idea that if we keep moving the path we're going, maybe don't end up where you want to be. So it took a step back. We're looking at the complete network architecture for mobile internet. And we have a solution. I spoke about it somewhat today. So the idea there is really to understand fundamentally what will work, what won't, and then come back to the table. Of course, the world is moving ahead, so you can't just go off and do something. So we then have to come back and look at the points of connection, what's the evolution versus revolution. So there's a number of strategic issues. But one nice thing is that there are a couple of emerging technologies which have to do with programmability and virtualization, which are pushing their way down into wireless devices, base stations, routers in the network. It's really cool because now you can program these devices to do things differently, which you couldn't have in the past. You'd have to rip out the equipment, put in something new. Now you can more easily upgrade those functions. So we think that evolution will eventually lead to revolution simply by constantly changing systems, and that's more likely to happen. So I think the IEEE standardization process has played an amazingly important role in all of this. And I'm not saying it because you guys are from IEEE, but in fact, if you look at the wireless industry, there was the ITU track, which is the International Telecommunications Union. Standards are expensive. Only the big companies could play a role. IEEE decided to work on lightweight industry standards like Wi-Fi, the IEEE 802.11, is one of the most ubiquitous wireless technologies now, and it's cheap and available. And a lot has to do with the IEEE model of let engineers go out and make some small standards, and those can later grow into big products. And so we really are into that model.
Right.
And so there is, of course, today there are a lot of IEEE standards, some more successful than others. 802.16 is another one which is competing with other standards like LTE. But in each case, it's helped to open up the market, give more choices, and what I like is that it's run by technologists and engineers and doesn't have a large political component. So IEEE has been great. Now, in terms of I'm also active in IEEE Communications Society myself, and we we count on the ecosystem of conferences, student participation, so education, awareness, dissemination of the journals like IEEE Transaction on Networking, which I've edited in the past. So all these are very important to making all this happen. So we think the IEEE is very important, no doubt. And you asked about the government. So government is another element in all of this. So in the last 5 years, the US federal government has been investing more in research on information technology. IEEE has lobbied for that. There's been a lot of reasons why we are beginning to see a lot more support for fundamental research. So I mentioned this issue of spectrum. That's an area where the government is playing a leading role. So certainly federal government support of research is very valuable, and it seems to be going in the right direction.